the mud or soft ground, it cannot fly up. It has to crash immediately. According to the prediction of the investigating committee, Russian investigating committee, the plane without a wing, you have to remember that they claim that they lost 1/3 of the wing at this point, so there has no wing already on one side, was able to fly up, then a little bit horizontal, fly up again, and cross this black line, which was disregarded by this investigating committee for some reason, that measured the real, in my opinion, elevation of this airplane. Now, this is this wing that was found 111 meters from the verge. So it means that, and you can see the green spot, so it means that in this area there's some forest, trees, and so this particular wing would have to fly through this forest, and somehow it didn't leave any marks. So that again, in my opinion, made that this assumption or this conclusion of Russian investigating committee is not correct. In fact, the independent evaluation of the black boxes produced this curve, which means that the plane never hit the verge and flew over, but something happened in this area, in fact in this area, which drastically changed the orientation of the plane, and that was attributed by one of the experts from Australia to explosion of the airplane, basically, in this case, in this location. But my work was focused on simulation of the crash of the plane to the verge, because at that time I didn't know that maybe other possibilities also exist. So I built the airplane model with putting, I say I built it, but of course my graduate students did it, with all utmost care to build the wing properly. Now, at the same time, we didn't want to make the wing too strong. So basically our wing is based on skin, the longitudinal beams, and those horizontal parts. But we didn't add this particular part, which is in front of the wing. When the airplane lands, you can see flaps going down, and the front part is forward, pushing weaker. At the same time, since the report said that the tree was between 30 to 40 centimeters, we used 44 centimeters to make it bigger by 10% to be on the safe side in our simulations. The material parameters for the trees is, of course, orthotropic, cylindrically orthotropic material. The properties can be taken from the literature. Aluminum is taken from the Russian side for this Russian airplane, and these are the LS Dyna material, model material plastic kinematic for the aluminum, and elastic orthotropic for the verge. This is how the internal structure of the wing looks like. We, to validate our test, to validate our model, we use some of the tests that were done by other colleagues, and this is, for example, validation of the wing front with the gelatin shot into the model of this wing. So you can see a deformation on the left and our prediction on the right, and below you can see the load and displacement as a function of time. The fuselage validation was done using the published model by published test done at NASA Langley, this drop test, and they also use a simulation, I think, with LS-DYNA. So we kind of recalculated or reproduced the results using our model, and again, the validation was satisfactory. Now, to make sure that we cover all the bases, we use parametric studies for simulations. We use different velocities within the framework of the report, of the official report, which is the maximum, and the velocity of this plane was about 80 meters per second. So we used, for example, one of the cases was 77 horizontal and 19.2 vertical up. The mass is 78,600 kilograms with about 7 tons of fuel. You can see the other dimensions. The density of the birch was also increased to make sure that we make stronger, basically, birch for our simulation. And these are the simulations. So the yellow is that birch. Of course, we don't have trees. We just use the trunk. And the airplane, from that distance, is huge airplane. The wingspan is almost 50 meters. It's more than 50 meters long, capable to run with, fly with 100 people inside. So those simulations show basically there's a damage. You can see some flying material, flying of aluminum from the front edge. Close up, you can see within the time is on the left corner here in seconds. So in times 0.02, the birch is basically broken due to dynamic load that experience exerted by the longitudinal first beam of the wing. So I presented this work to a parliamentary committee in Poland, and recently, a couple of weeks ago, to a European Union parliamentary committee, as they were interested in those results due to the fact that 9 of the generals who died in this crash was NATO generals. You know, they were very, very interesting to see different take, let's say, on this explanation of this plane. So you can see here that, of course, once I have the model, I can see the stresses, vibrations, waves moving, and so on. But what is interesting that in all cases the front part is damaged because this is very thin aluminum and leaves about 60 centimeters gap. And when we had opportunity to look into the pictures of the debris of the whatever left after the plane crashed, the whole edge, front edge, is intact. There is no such gap. So that was another surprising to me, that how they could claim that the birch was the case, you know, causing the separation of the wing if the front edge is not destroyed. So these were my conclusion, that in fact based on the parameters provided in the official report, the model shows that the wing of this plane cuts through the birch for every analysis scenario. Now, because this, as I showed you, the wing was found 111 meters in front, and together with another professor, Professor Brown, who is expert in aerodynamics, we tried to model flight of this free separated wing to see how it's supposed to fly. So again, you can see the picture from the satellite. This is the tree. This is the location of the wing, and using CFX, ANSYS CFX analysis and LS-DYNA, we found first the flow of the stream of the air around the wing, and this is just before it is separated from the invisible airplane, and this is after it is separated. So you can see the generation of the turbulence on the back side of the wing as anybody who is studying aerodynamics would expect. Same thing with the dynamic pressure. If the plane is flying, in the right way, the dynamic pressure, the highest is on the front edge. The other pressures produce the lift of the airplane, and the moment that you separate the wing, the forces will rotate the position of the wing, and therefore the pressure distributes over the front side of the wing, creates a strong force, and pressure times area basically is the drag force. So in LS9 we use arbitrary Lagrangian Eulerian method, constrained Lagrangian solid keywords, and we simulated this in invisible air, and in this moment it is separated. So for the first second the wing is flying together with invisible airplane, and then it's left out to behave as physics or numerical simulations would show that. Now we are flying from behind, and now it's separated, so you can see it's kind of chaotic movement, flying like a leaf almost. Of course, the speed is much higher. And again from the side, now it's separated, and it's kind of whatever the pressure and the position of the wing would allow this to do. So if we put the movement of the center of mass of this wing piece in three-dimensional space, we can see that this is with the moment of separation, that the plane has the tendency to move in the direction of the airplane, but also to the right side of the airplane, which is good because this is exactly how it was found on in that area. However, if we connect this curve to the location of the verge at 6.5 meters away, this curve would predict that the wing would hit the ground about 12 meters away with the velocity 100 kilometers per hour, not 111 meters as it was found. And of course, we remember that between that part and somewhere here, there's some other trees. So there's no ability for the wing to go up and skip those trees, basically. It has the tendency rather to go down. So my prediction of the separation is this point, and also at 26 meters above the ground, because if it is anything below, it will have no space to move to the right side. Okay, you need to give that space for the aerodynamics to allow a movement of the wing. So eventually it will move a little bit to the right, and it needs to move 10 meters. So now, also if it was separated exactly in this location, because again, this is the path of the airplane, so the wing was somewhere here, you can see that there's no any trees. So this part can fly and stop on the wall of trees, which also makes sense. Now, at the same time, if it was separated at this location, which is at 26 meters, and about 70 meters away from the verge, based on this prediction, it will hit the trees at velocity about 40 kilometers per hour. And this is 600 kilograms mass of aluminum. So if it hits with about 40 kilometers per hour, a bunch of trees, they will break, and it is consistent. It looks, at least in my eyes, consistent to that velocity, not 100 kilometers per hour. So this is my other conclusion, that in fact my prediction shows, Dr. Brown's prediction shows that that separation happened about 70 meters away from the verge, 26 meters above, which is consistent with this black line, which is measured by TAFs and recorded in the black boxes that was disregarded by investigating committee. These are all the tests, all the measurements of the black boxes. So this is the location of the birch. What we found that about that time where I predict the location where the birch, where the wings supposed to be separated, you have two sharp accelerations. Nobody knows what those accelerations are produced by, but definitely they are not by the birch because they are later in the time. They were not explained in the investigating committee. There were, of course, other shortcomings of the investigation. You know, 1 hour after the crash, it was announced that it was the pilot error, and basically anything that they were looked for were to substantiate this announcement, and anything that was not substantiating the announcement that this is pilot error, then it was disregarded. So investigation standards were violated, as I understand from ICAO requirements. Key evidence not secured, wreckage of the plane destroyed the next day, crash site not secured and not preserved, the area cleanup, trees were cut down, even grass was burned a few days later. Coffins with victims were sent to Poland, sealed, and until 2 years now, nobody has the right to open those coffins. And when one of the American experts, Dr. Baden, who is the one who made the autopsy for the President Kennedy, went on the request of families that secured autopsy for their loved one. The Polish government will not allow him in, even to make to work as an to do observations of this autopsy. So evidence manipulated, location of debris change. You know, we have evidence like satellite pictures that shows that some of the parts of the airplane was moved from one day to another, and then in the report they are marked as the second position is the right one, not the first, the previous day. A Russian report contains statements that do not appear on the transcript from the cockpit voice recorder. Evidence withheld, as I said, 2 years after the wreckage of the plane. Black boxes and other key evidence is still in Russia, and no international expert is allowed to go over there and to touch it or to see firsthand. So I will be happy to answer any questions. At the same time, I would like to show how the evidence was taken care of this plane the 2 days after the crash. Thank you.
Thanks very much. So we have a few minutes for the Q&A, and then we'll have a 20-minute break. So any questions? Rob?